Thank you very much, Julie, and thank you for having me. So I'm going to be talking briefly about preventing slips, trips and falls. And some people might think an hour is not brief enough, but those people have not sat through my 2-day training on preventing slips, trips and falls. So you're very lucky today to be having about an hour with a little time for questions. So a bit of background on me. The reason I'm here talking to you today is I spent 15 years with the UK regulator, the Health and Safety Executive, working in their science division, full-time on preventing slips, trips and falls. So undertaking HSE's research into why people fall over, supporting HSE inspectors going out and looking at investigating slip accidents, and helping clients and customers on behalf of HSE reduce their risk of slips, trips and falls and prevent incidents. And I went independent and set up my own consultancy when HSE changed its science focus about nearly 5 years ago now. And we've been doing exactly the same thing since. So for my sins, in January, I'll be entering my 20th year doing nothing but preventing slips, trips and falls. So if you need a question answering on the topic, I am the biggest nerd out there. I was the technical lead for the falls prevention team over at HSE, and I'm currently the workplace lead for workplace falls prevention for the IEA Slips, Trips and Falls Technical Committee. And I've spoken in a number of interesting places on preventing falls. So what we're going to talk about today will be a brief overview of the science underpinning some of the reasons that people fall over and what you can do to prevent it. So there shouldn't be too much in terms of national building codes and regulation. It's more about those fundamental principles of what we can do to reduce risk. Now, my business partner, Rachel, was also at HSE. She was a project manager over there who worked largely on the reactive incident support work portfolio. So we've got excellent project management. It's worth mentioning that Rachel is also my wife. So she project manages all aspects of my life and does so very well. So we're here to talk about preventing slips, trips and falls. And fundamentally, this is the reason why. So I'm going to show a quick video clip. And I show this because it was shared with me at a steel stockholding event in the UK where I spoke, and they asked me to share it because they learned a lot of lessons from this incident. And what we're going to see is an individual working on the back of a vehicle. The vehicle has a cradle in it for storing the rolls of steel because they're extremely heavy. They want to make sure that they don't dislodge from the vehicle during transport. When that's not in use, they cover the cradle up with metal plates. Now, in this case, somebody's working on the back of the vehicle. They step on one of the plates, which hasn't been secured. It's dropped in place because they're very heavy, and the plate shifts and the individual falls from the vehicle. Now, we'll see in the background somebody walking along with a steel roll on a lift, and they've managed the risk of that lift breaking, the load dropping, by having the individual walk out of the area of contact, out of the line of fire. They're managing the risk of dealing with this high impact potential problem with the heavy steel, but very little thought has gone into preventing the simple fall from accessing the back of the vehicle. So as he's working, and I hope that the video is playing for everyone, there's no sound, he'll drop this second plate in place and you'll see it bounces. It doesn't quite sit right. And then as he treads on it, it shifts and he falls. And initially he only falls within the on the same level. He hits the bottom of the deck, and then unfortunately, because of where he is, he rotates off and lands on the floor. Very, very nasty incident. He broke his hip, I believe, both his legs, and because his hard hat isn't strapped on and it comes off, he receives a very nasty head injury. So this was a significant incident for the organisation, and the individual, I think, ended up with about 8 months off work. When you look at this video, it's very easy to identify a number of things that could be done to reduce those risks. And in fact, the business did that. They've changed the way that the loading is done here. I believe there's now a portable loading dock where they pull up the vehicle so that they have edge protection and the individuals don't work exposed to that danger of a fall from height anymore. The problem is, and this is very common with all slips, trips and falls, all those good ideas came in reactively after the incident, rather than somebody looking at it proactively and saying, actually, there's a number of things wrong here, something could cause a serious injury. And this is one of the big problems we have. Typically, organisations are reactive rather than proactive, especially around slips and trips on the level, which are seen as minor incidents. In some cases, they're seen as quite funny if you get away without an injury. And they're also seen as something that you can't do anything about. Actually, you really can. Slips, trips and falls can be very easily managed, and the solutions are typically quite simple. The problem is getting the right solution for the problem that you've got. So selecting that solution is not usually evidence-based. It's based on somebody's good idea. Everybody has had a slip or a trip, and when one happens, a number of assumptions are made. Quite often, we assume that it's all human error. There's not much we can do about it. And then 3 months down the line, we have another one, and we try and work out why people are continuing to make these human errors. But also, we see all sorts of things where people, for example, will have a slip on the floor, and the solution is, we will remove the step in this area, and that will help with trips. Well, it's not addressing the root cause problem. So I'm going to talk very briefly about a number of the different factors that can give rise to a risk of people slipping, tripping, or falling. But before we get there, gathering that evidence is critical. So understanding where falls are happening or where near misses are happening helps you be proactive. It helps you do something about those hazards before that one nasty incident, rather than standing around an injured person and then trying to work out what we can do about the problem. Now, gathering the evidence for slips, trips and falls is quite challenging. The typical near miss is seen as a slip, a trip or a fall where nobody is injured, or if you're being cynical, where no claim is put in. In reality, the true near miss is the slip or trip where you don't even lose your balance. You catch yourself and you carry on. And those are almost never reported because it's not seen as an incident or an issue. In fact, most people after 2 or 3 steps will have forgotten it's happened. So there's a problem that slips, trips and falls are generally significantly underreported, even in the near miss stage. So it's very hard to capture good quality information, to learn from the incidents you have had or the near misses you've had, and to do something proactive before that one big incident. Quite often, the first clue that there's something wrong at all is a significant injury. And I've worked with a large number of businesses where, unfortunately, the first time they realized there was something that could be done to manage the risk was after a fatal accident. And then we've gone in, we've looked at the design of the environment or the setup on the stairs or whatever it might be, and there's some significant defects that have given rise to risk and have contributed significantly to that incident. But the first time they know about it is where somebody has died in that situation. So gathering that better data and using it, tracking it, doing something with it allows you to be proactive and manage those risks before that one big incident. So I'm going to talk about one example in a minute of how to gather that data. But first, I thought I'd talk through an example of something that we saw when I was working at HSE. So my team did some work at the National Gallery in London. Very, very busy public building, about 4 million visitors a year, and they have a very good reporting system there. They get about 15 reportable incidents each year to members of the public at one of their main entrances. And so the riddle there refers to the UK reporting system for injuries and dangerous occurrences. There was a question that was asked by the local council in London is 15 reportable incidents just the price of doing business when your building has 4 million visitors a year, or is there something more they could do to manage risk? And they were tracking near misses as well. So each of the security guards were given a pen and paper, and if they spotted anything that wasn't reported, they were just asked to jot it down. And they had a few hundred a year of these near miss reports. So they were able to identify that this one entrance with a very small single step was causing significant issues. So we monitored that entrance. I'm not suggesting this is how we go about doing our data gathering and our near miss analysis, because it nearly broke a member of my team, because on the day that we filmed 3 different entrances for 6 hours each, and we had 12,500 journeys. 12,500 people came in and out of those entrances, and we had to look at each one and look for anyone who stumbled, anyone who misstepped, anyone who had an incident. On that day, no incidents were reported. So nobody reported any incident, near miss or otherwise, to the gallery, and none of their security staff picked up on any slips, trips, falls, or near misses. So as far as they're concerned, they've had a perfect day. That's, there's no problem there whatsoever. They've had plenty of visitors, 12,500, no problem. On camera, we captured 466 incidents, and they range from minor missteps, people catching their feet, but they also included 9 people who were obviously injured. We had some cut legs, we had some people who struggled to walk away without help, twisted their ankles, a couple of very, very nasty falls where the people were very shaken for a while. And all of these are sort of hidden because they're not reported and because nobody's been able to capture them. The first time there's an incident on that stair may be one of those 15 reportable incidents a year. So if you took that as an average day, the filming suggests that there's maybe 250,000 of these small incidents per year, and possibly as many as 4,500 people who are receiving some form of minor injury in that area. What this allowed us to do with the evidence, understanding which factors in the area were giving rise to risk and where people were having the problems, was make some recommendations for changes to that particular entrance. And this is one of the most heavily controlled Grade 1 listed buildings in London. Very, very difficult to get building control to approve any changes to those entrances. But some very minor modifications were made, non-permanent modifications to the shape of the step, the design of the matting outdoors, and a number of other things. We went back and filmed again. We had another similar day, similar time of year, similar weather, similar number of journeys, and the incident rate dropped by about a third. And that was all going into the building. So even on a very carefully controlled, very old building in the centre of London, using the evidence we had, we were able to make a significant difference to risk. And that suggests maybe 1,500 fewer people injured each year and 5 fewer of these serious reportable incidents. So you can do something about slips, trips and falls with the right evidence. I'm not suggesting this is the way we all go about gathering our evidence, but it's not always as complicated as that. So one way to gather the evidence is the Proactively system, and I'm sure some of you will be familiar with it. This is a system that we work with. We work closely with Proactively because I've been doing this training for coming up for 20 years, and for the longest time, until I met Alison and I found Proactively, one of the questions I was always asked was, you've told us how reporting fails on slips, trips and falls. What does good reporting look like? And the answer was always, I don't really know, because I'd yet to see it. This is one really good example of a good reporting system for a number of reasons. So the organisation designs their own reporting forms, and they could be around risk, so they could be near misses, they could be incident investigations, but they can also be about productivity and about cleaning and maintenance schedules, anything that the organisation wants to gather data on. And they design these forms, and they can be a mix of free text boxes, multiple choice questions, single choice questions. There's the option to include photographs, GPS tags, individual signatures if you're doing incident work. So they're very, very flexible, and they can be designed to gather the information the organisation needs. They can then be issued to different teams. So maintenance teams might need a different set of forms to health and safety teams, to frontline operators. Once you're gathering the data, anything that's reported through that mobile app, and the mobile app has the power that the individual can report at the point of contact. They can take a picture, they can log the exact location of the incident, makes that data much easier to query. Once it's reported, it's sent to a web-based dashboard that the people who are authorized to see the reports can then interrogate, and this is another critical step. They can look at how many incidents there are, what the causes are, what common locations are happening, how quickly actions are being assigned and fixed. And that leads us to a really powerful feedback loop. So the forms are designed by the individual organization to get the information they need. That then leads into the reporting system, and everybody who has access to a mobile device on site then has the ability to report anything they see, whether it's a maintenance issue, a near miss, a hazard, or an incident. That then is assigned actions, and they can be reviewed, they can be made sure that they are completed in a timely fashion, and the problem is fixed. But the critical thing I like about this system is there is an option for the person on the web-based dashboard to send quick feedback to the reporter via the mobile device. So they will get a message that says, thanks for the report, we're looking into this, or this is what we plan to do. And that's a critical part of engagement with the reporting process. Because if you report a maintenance defect, it's not necessarily something an organization can fix overnight. It might need budget assigning, it might need to find someone who can do the work. So it may take time to fix that issue. If you're writing the issue down on a piece of paper and popping it in a box, and then for a month, 2 months, you work in that area and you see nothing has been done about the problem you reported, it discourages people from engaging with that system and from reporting again. Whereas here, there's instant feedback. So the individual feels that their feedback has been listened to and something is being done about it. And then ultimately, you can analyze that data. And if it's not quite giving you the information you want, that feeds right back to the start of the process, and you can either redesign the forms or you can add a new form to capture the information that's critical to the organization. So that's one way that's really effective of getting the reporting in. Now, the challenge is, once you've got some information, how do you actually stop the incidents? And for the most of the rest of this session, I'm going to talk about preventing slips, because preventing slips is a little bit more complicated than preventing trips. There's a few more things that go into it, so we'll cover that in some detail. And then I will talk briefly about preventing trips, and we'll finish by talking about preventing falls on stairs, which are a significant cause of serious and fatal injuries. Probably a depressing way to finish the session, but that's how it's set up, so bear with me. In terms of preventing slips, in the UK, the HSE, the Health and Safety Executive, looks at collective controls above personal controls. So the hierarchy of controls within the UK starts with flooring. If the floor is suitable and fit for purpose, offers enough slip resistance in its normal operating condition, then it protects everybody working in that environment. If the floor has contamination on it, whether that's water, dust, oil, it can change the slip resistance. So keeping contamination off flooring is very important, and the cleaning process is a critical part of keeping floors free from contamination. Right at the bottom of that hierarchy of controls is footwear, and it's at the bottom because it's personal protective equipment, so it's only protecting that one individual, it's only protecting them while they're wearing it and doing that job. However, it can be a very, very effective control for preventing slips. So I'll talk about all of these very briefly: flooring, contamination, cleaning, and footwear. Obviously, human factors plays a role throughout this. One of the most critical areas where human factors plays a role is the cleaning process, and we'll talk about that as we go through. Now, starting at the top of that hierarchy, there's excellent slip-resistant flooring available. So this is a fantastic piece of news, is that you can have a flooring product that will cope with being wet, will cope with having oil on it, and will still offer suitable slip resistance for people to work safely in that environment. And I work with a large fast food retailer. They've got a ceramic tile in their kitchens. It's not slippery when it's wet. It's not slippery when they spill cooking oil on it. And provided they keep it clean, which they can do and do, they manage to maintain that slip resistance on a daily, monthly, and yearly basis. So there's some fantastic products out there. The problem is, again, getting good data and getting good evidence. There are hundreds of different tests for how slippery a floor is, and very few of them are relevant to pedestrian slipping. What you're interested in answering is the question, how slippery is my floor when a person walks on it? And most of the tests out there don't actually address that. They don't simulate pedestrian walking properly, and the pass thresholds in some of those tests are meaningless. So there are lots of products out there that have been tested to a particular standard test that aren't actually helping manage risk. And it will depend on where they come from nationally. And it also means that an architect, a specifier, a building installer, if they want to use a particular floor surface, probably have an option of a flooring test that will tell them it is slip resistant. So it's very difficult to understand without relevant testing. Now, there are good relevant tests out there. We'll not go into test results, test numbers, test names, standards today, because I will lose the audience quicker than I could possibly imagine. But there are good tests out there, and it's about knowing where to go for that good information. Flooring will change over time. Some floor products, as they come off the production line, offer excellent slip resistance. And when they're tested in that condition, they will tell you that floor is fantastic. By the time they've been installed and had a first builder's clean, they may have lost almost all of their slip resistance. So you've purchased a product that you are on the understanding it's great. Once it's installed, immediately you've now got the lifespan of that product with it not offering the protection that it suggests that it did. And even flooring that is excellent in terms of its slip resistance will degrade over time. Some floors maintain their slip resistance for 20+ years. Some floors lose a lot of slip resistance very quickly, depending on wear, cleaning, the amount of walking on there, and so on. So it isn't just a case of getting something that ticks the box on day one and assuming that the problem is solved. This comes back to that ability to monitor near misses, incidents, and identify areas where perhaps the flooring has changed or the condition of the floor has changed. Now, profiled surfaces like metal checker plate are quite often involved in slips. I'll talk about those in a minute. And you can modify existing floor surfaces, whether it's coating them with a resin containing aggregate, whether it's an acid etch treatment. but it's never as effective a solution as specifying the right floor in the first place, because it's far more expensive to continue to modify an existing floor over its lifespan, and you need to be able to monitor that to make sure that the product is continuing to perform. It will often need to be reapplied. Some of the products, which claim to be all sorts of magical things, but in reality are typically an acid etch product, will modify the surface and will improve slip resistance, but the durability depends very much on the treatment used and the type of floor it's used on. I've seen acid etch treatments that last well over 12 months in hard wearing environments, and I've seen acid etch treatments that last less than a week in busy shopping centres. So it depends very much on that situation. I talked about metal checker plate flooring. So profiled flooring in general, and it isn't just metal floors like this, anything with a raised physical pattern. So a profiled quarry tile in a kitchen, a profiled ceramic tile in a building entrance. There is an assumption that when you walk on this, your footwear will interlock and you will gain some extra grip. In reality, what tends to happen is the footwear sits on the peak of that profile. So the profile surface is limiting the contact between the two surfaces, and particularly for metal flooring, either the surface is very, very smooth polished metal, or it becomes that way quite quickly with wear, and it offers very poor slip resistance. The problem is, when we look at that surface, we expect a good level of grip. And so the expectation that differs from reality catches people out. So for example, if you think about walking on ice, if you find a patch of ice, you can walk across it, you walk very differently, you walk very carefully, but you make it to the other side. When you find a patch of black ice and you weren't aware that the grip was going to change underfoot, that's when you have your accident. And these can be very, very similar. They can also sometimes be more difficult to keep clean and to maintain. So in this instance, we've got two pretty typical uses. We've got two stairs in manufacturing environments. Both of them have had to be modified after installation to improve slip resistance. There's obviously been a history of incidents on these stairs. So one's had a series of different grip strips over the years on the left there, and the one on the right's had some glass reinforced plastic treads added to it. So profiled surfaces are not necessarily as slip resistant as people expect. The next section of that hierarchy is contamination. A clean, dry flooring is not typically slippery. Even if it's very, very shiny and smooth and reflective, it is not an inherently slippery surface. In fact, smooth, shiny, polished surfaces, when they're completely clean and dry and there's no contamination between the footwear and the floor, offer the most grip that you will get from any surface because you get fantastic material contact. The problem is that you only need a tiny amount of contamination on a smooth floor to increase the level of slip resistance significantly. So if you think about water, for example, the film of water that's created by an average weight pedestrian as they walk is about 2 microns, 2 millionths of a meter. Everything else is squeezed out of that contact patch. So in reality, there's no difference in risk between a floor that's got ½ an inch of water on it and a floor that's just slightly damp because of condensation or because of a recent cleaning process. The risk is exactly the same. So you can very successfully manage slip risk by controlling contamination and stopping it getting onto smooth floors. But you need to be very confident that your processes are actually achieving that, because only a tiny amount of contaminant, such as the moisture that's on somebody's foot when they come in from outdoors, can make that level of risk spike. Preventing contamination getting on the floor is useful for a number of reasons. Obviously, my top one is it prevents people slipping, but it also increases efficiency. So if you've not got contaminant getting onto the floor, you're not spending time cleaning it off the floor. So that helps improve efficiency. And if you're in a manufacturing environment, it reduces waste. If it's product coming off the production line, that either needs to go back into the start of the production line and be reworked, or it needs to be thrown away. So it's wastage. So preventing contamination getting on the floor is beneficial for a number of reasons. A lot of manufacturing processes are naturally, they produce contaminants that you cannot stop getting on the floor, whether that's a manufacturing environment, whether it's a catering environment where the oil and grease in the air from the deep fat fryers will naturally settle on the floor. In that case, either can you prevent it getting onto the walkways and the commonly used pedestrian areas, or prevent it getting onto the smooth surfaces that are high risk. If the floor in that environment will cope with that contamination, so if you've got a floor that copes with being wet and your manufacturing process or your kitchen process creates water on that surface, there's no problem because the risk is managed by the floor. But if you're controlling the contaminant, you need to think about where it goes. And then the link between flooring and contamination is obviously cleaning, because cleaning removes that contamination from the floor. And as we looked at on the last slide, clean, dry floors are not typically slippery. Very, very rare exceptions. Some footwear on smooth, clean, dry surfaces can cause slips. Leather soles on footwear it's an unpredictable footwear material, and high heels with a very small heel tip, so a stiletto heel, often to give you good wear characteristics, so those heels don't wear out very, very quickly, either have a very hard plastic or a metal heel tip on them. And that sometimes gives very poor friction on those surfaces. So it isn't the heel itself that's the problem, it's the contact area and the material that's giving you the challenge. In terms of cleaning a floor successfully, technique is critical. And I'm going to show a couple of slides in a minute that illustrate this. All floors can be successfully cleaned, but the cleaning regime needs to be appropriate to the contaminant on the floor and the type of floor. It isn't just a case of a mop and a bucket will clean everything, or a machine will clean everything. It needs to be operated correctly and done appropriately. Even good slip resistant flooring can be cleaned to both an aesthetic and a hygienic standard. So there are two arguments that tend to come back when looking at slip resistant flooring. One is, well, it doesn't look as good as regular flooring. And actually slip resistance comes from the surface finish. So with the exception of a highly polished gloss mirror finish, you can have any material you like in any aesthetic finish with a good level of slip resistance, provided the upper surface has enough roughness to cope with whatever contaminants are common. The other argument is, well, we can't put slip resistant flooring in because you can't clean it, and then it's worse than what we've got. Or if you're in a manufacturing food environment, or if you're in a healthcare environment, well, it won't work for us because we have hygiene restrictions. And I did the research that HSE did on cleaning back in about 2005, and we worked primarily in healthcare environments and food manufacturing environments where hygiene restrictions are very tight. And we found that they were very good at cleaning slip-resistant flooring successfully, but the technique is critical. In terms of risk management, the cleaning process itself is often the one time that many floors get wet. So smooth, shiny flooring in an internal office environment that's not near an entrance or near a drinks dispenser isn't typically going to get wet in its normal use. So it doesn't matter that it's a smooth, shiny, polished floor. The problem is, the one time that that floor gets cleaned, it's typically a wet process, and the risk is suddenly significant, both for the cleaning staff and for anybody else using the area during that process. So cleaning needs managing, it needs planning. It isn't just something where you can give somebody a mop and bucket and assume that A, they can successfully clean a floor, and B, they can do it without introducing other risks. So putting out a wet floor sign while the cleaning is going on is not everything reasonably practicable that can be done. And that's the wording of the UK law, what you need to demonstrate you've done. But it works for all organisations. Putting out a wet floor sign on its own does not guarantee that the individual sees it, that they understand what hazard it relates to, and that they're able to adapt their behaviour to avoid that particular hazard or to change the level of risk that's presented to them. Having a wet floor sign out as part of your cleaning process is one part of the puzzle. It may help in certain situations, but it isn't the be all and end all. The other considerations around how the cleaning is done, when the cleaning is done, how people are excluded from areas, etc., are all very, very important. Obviously, the key message is, wherever possible, avoid leaving smooth, shiny floors wet. So dry mopping or barriering the area off until it's completely dried. All very practical ideas and all very, very simple, but they're the things that for 20 years I see people getting wrong time and again. And they're some of the easiest ones to fix. You don't need to buy new equipment. You don't need to spend any more time doing it. You just need to think about the process. So talking about simple things, the use of detergent is one that we see done time and time again in an incorrect manner, and it gives rise to risk. Detergent's quite simple. You need to have some detergent in your solution if you're going to remove oil and grease from a floor. The concentration is obviously important. And if you think about washing up and doing the dishes at home, you need to get oil, you need to get detergent in there to get greasy pans and pots clean. They need to have some time to soak if they're heavily soiled, so a bit of contact time is important. And in the context of flooring, the HSE research has shown that 30 seconds to a minute of contact time on the floor can make a big difference to the amount of oil and grease that's lifted into that suspension. The critical thing that I see go wrong time and again is the removal of the solution. quite often people will either apply with a machine or mop down a small amount of solution with a well-rung mop because they don't want to make the floor slippery. But as we've talked about, if any solution is going down and the floor is smooth, it will be slippery. The volume is not particularly relevant. But then the solution is mopped around a bit and left to air dry. And what happens there is, as the water evaporates, all the oil, grease, detergent in suspension is dropped back on the floor. So the oil and grease builds up over time, and it can compromise even a good slip-resistant floor. So the removal of the solution is really important after that cleaning phase, so the dirt is taken away and disposed of correctly. Obviously, a detergent solution also has a finite amount of use before it is saturated with oil and grease. And it's very common knowledge that one bucket cleans one factory floor, regardless of how big your factory wing is. I did some work in a food factory where they came out and they put signs, barriers out, they excluded people from the area, and then they tipped the whole bucket of solution on the floor, really saturated the floor. And it was a very effective cleaning process. You could tell because when they threw the bucket on the floor, it looked like a pint of Guinness. It was absolutely jet black because the wing of the factory they cleaned was a mile long and half a mile wide, but they used one bucket all day. So that solution needs to be replaced as appropriate. Now, I can't get away with being a scientist without showing you a couple of graphs. So we're going to have a couple of graphs here. These are just looking at some research that was done on using the correct method to clean and how effective it is. So this was all done in large commercial kitchens, so environments that have hygiene standards and they're making food, so they've got a requirement to keep the floors clean as well as safety requirements. And it was research done by a colleague of mine in Canada who went into large commercial kitchens. He asked them to clean the floor, so he measured how much grease was on the floor. Then he asked them to clean it in the way they normally would, made it very clear he wasn't assessing them, he was just looking at how effective different cleaning techniques were. And the red bar there, with all these different detergents, was the amount of oil and grease left on the floor after it had been cleaned by the staff in the restaurants. And in some cases, 75% of the grease is still on the floor after they've done their usual regular daily clean. What he then did was, he cleaned with an improved cleaning regime. So he took their chemicals, their equipment, and all he did was clean the floor with his improved regime. And in most cases, there's a significant reduction, that's the blue bar, in the amount of grease left on the floor. We'll come back to DASH in a minute, which is very different. His improved cleaning regime was, he took their equipment, their mops, their buckets, their chemicals, and he read the label on the chemical bottle and he followed the instructions. And this is where human error creeps in with cleaning. We clean so often, and usually cleaning is not the primary job role of a lot of people doing it. If you're running a facilities management company, you've got professional cleaning crew on site who are doing nothing but cleaning all day. But in many cases, cleaning is what you do at the end of your shift, manufacturing something, cooking something, or sorting out, hospitality environments for the members of the public. And it's the last thing you do before you get to go home. And it's very easy to fall into bad habits, especially if people don't understand which bits of the cleaning process are important. So in this case, by using the same time, the same equipment, and the same chemicals, he got a much better result by following the instructions. Now, the outlier there is DASH. If you look, it's one of the very lowest, in fact, it's, almost the lowest red bar, meaning that the staff in that kitchen, the way they were cleaning it was very effective. Only about 20–25% of the oil and grease was still on the floor when they finished. I suspect that the instructions on the DASH bottle weren't actually as good as what the staff were already doing in that environment. But the technique makes an enormous difference. And I've upset a lot of chemical salespeople saying this, but technique is at least as critical as chemical, if not much more so. And then looking at hygiene cleaning, so talking about the idea that you can't install slip-resistant flooring in critical hygiene environments such as healthcare, we did some research when I was at the laboratory, and we looked at a number of hospitals across England and Wales, and we measured the slip resistance of the flooring, and we measured the amount of bacteria growing on the flooring, which is an eye-opening experience. And we compared these two types of floor. So the typical smooth, shiny, highly polished ward floors that are very easy to make look clean, and the more aggressive slip resistant safety vinyl flooring that you get in the wet areas, such as the shower rooms and the bathrooms and the toilets. And we looked at both the slip resistance and the bacterial growth. And this is obviously a very self-explanatory graph, so I'll let you interpret it yourself. It's not the easiest bit of data to look at, but what we've got here is flooring 8A on the very left there is the smoothest, shiniest, most polished and highest risk floor from a slips point of view. And as we run through up to 12A, 12B and 12C, the 12s up there are the most aggressive slip resistant safety vinyls we saw. And what we found was there was absolutely no relationship between how slip resistant a floor was when it was wet and how much bacteria was growing on it. So the early floor 8s and floor 9s there, and even some of the 10s, which had a moderate level of slip resistance, all had, the red bar is as we found them uncleaned, they all had significant amounts of bacteria on them. When we did the cleaning, we asked the ward staff to do the cleaning for us as they normally would. And again, we made it very clear we weren't assessing them individually. We were looking at the current NHS cleaning in England and Wales to see how effective it was. In many cases, there was a lot of residual bacteria still after the cleaning process, particularly on the smoother floors. Floors 12A, 12B and 12C, the most aggressive safety floors, had some of the lowest values of bacteria as we found them. And in fact, 12C was sterile as we found it. You could eat your food off it. I suspect some of the reason for that is it's very easy to make the smooth, shiny floors look clean. If you skate a mop over them, all the black marks come off, all the scuffs, all the dust, so they look clean. But actually the cleaning isn't as effective. Whereas perhaps with the more aggressive safety floors, they're having to take stains off the floor and be a little bit more progressive with the way that they're doing the cleaning, but actually it's being more effective. So there isn't a relationship between cleanability and slip resistance. The relationship is between cleaning method and cleaning technique and slip resistance and hygiene. Just as a final example here, this is one that HSE colleague of mine used a lot, and we used to use in our training, but I think it's a very important one about the human factors element. A lot of cleaning relies on the individual who is doing that task. And if they do it right and they're well trained and they understand the importance of their role, the chance of reducing the risk of somebody slipping is significantly higher. So in this case, we've got a train station, large train station in the UK. It's got a smooth, shiny floor that gets slippery when it's wet. There's a number of sources of contamination in the train station at the entrances and off from the platforms. But one of them at the time that we came across this example was the flower stall here, where people would remove the flowers and you could see there are a couple of puddles where they drip water on the floor. So they have these roving cleaners and they're trained to be very reactive. The call goes out, the individual goes to the area and deals with the spill. And a very dedicated colleague of mine was waiting for his train and the call went out over the tannoy system, please come and clean up at the flower stall. And he was there within, I believe it's 38 seconds. So he's really understood that part of his job. He's got that in his head and he's done a brilliant job of getting there very quickly to deal with that wet spill. When he got to the spill, he dipped his mop in his bucket and dragged it all the way across 10 meters to the spill, leaving a trail of water across the main entrance to one of the busiest platforms in that large train station. Now, it might be that he's having a bad day, it might be that he's very awkward, but I suspect nobody has trained him in why he's been asked to do what he's doing. In his mind, he's been asked to get out there and clean is drag the mop around and the mess is gone. Actually, if it had been explained, we're cleaning to take water off that floor to stop people slipping. On his cart, he's got towels, paper towels, cloths, anything that would have picked that spill up and dried it up without increasing the risk. So the management of cleaning is very, very important. So in terms of cleaning, you need to ensure that it's effective and relevant to the floors and the contaminants you've got so that it is effectively cleaning the floor, but safety flooring is no barrier to that. The risks actually introduced by the cleaning process, such as the dragging of the wet mop, such as the wetting of smooth floors, all needs thinking about and needs managing. But cleaning as a whole process needs managing. It isn't something you assume that somebody can do. It requires training, it requires supervision, and it requires some effort. It can help or hinder. It can be a really critical and easy way to minimize some of the risks that might be present in different work environments and public spaces, but it needs thinking about. And then finally, on that hierarchy of controls for slips is footwear. So as we talked about, it's lowest down on that hierarchy because it's personal protection. But actually, it's often the easiest and the cheapest control to implement compared to ripping up flooring and replacing it, or treating flooring, or buying in new equipment if you need to change your cleaning regime. Actually, providing footwear does protect the individuals. There are some very, very good slip resistant footwear out there. and it can pretty much eliminate the risk of slipping in very challenging environments. For some staff, it might be the only control that's available. So the cleaning staff we've just talked about have to be on those smooth, shiny floors while they're wet, because it's their job to wet them as part of that cleaning process. Peripatetic workers, outdoor working staff who are outside in the elements, no control over the weather, perhaps very little control over floor surfaces, or even if they're going into other people's premises, that's a risk that cannot be controlled. Logistics drivers, delivery drivers, maintenance engineers. Footwear can provide a fantastic level of protection for staff in those job roles. In a lot of organisations, PPE footwear will already be provided, whether it's for toe protection, whether it's part of a uniform policy, but there will be footwear provided. So it could be a completely zero cost solution. If you can identify a piece of footwear that offers greater slip resistance than what's currently being issued, as the old footwear wears out, you issue the new footwear and you've got yourself a better solution. The big challenge, very much like flooring, is that getting good information is difficult. So there is a standard that is present throughout Europe, and it's the same test method that's used throughout the United States as well for how to test the slip resistance of footwear. And that standard does not simulate the conditions under which people slip, and it doesn't measure the important bit of information you want to know, which is at what point, given this combination of floor, contaminant and footwear, does it fail? How far can we go? How much grip does it offer before we fail? That isn't what the test measures. So it's fundamentally flawed. The challenge in Europe is that that's interpreted using the standards in the PPE regulations. Those standards don't challenge the footwear. They're not designed to give a relevant level of risk. They're designed to pass the footwear that manufacturers make, because the standards are written by manufacturers largely, because they're the ones with the vested interest and the ones with the time and the money to invest in attending and writing standards. So there's a big challenge that at the moment, you can buy a piece of footwear that has gone through a standard test, has achieved a particular level of performance, is branded as slip resistant and has that stamped on the sole. You can get it into the workplace and find that it doesn't do a job for you. And that's counterproductive, because a lot of organizations will say to me, well, we've tried footwear and it doesn't work, so it must be human error that's causing these problems, when actually the reason is that the footwear they've got isn't living up to the promises that it makes on the box. There was a university in California did some research that said, using the current standard, looking in Europe and in the States, if you buy a piece of footwear that's branded slip resistant, you might as well flip a coin. About half of them on the market are any good and half of them aren't. But the ones that are good are very, very good. You can walk on smooth sheet steel with 6 litres a minute of water flowing down it at about 25 degrees and not slip. Once you've done that, it's really eye-opening how good some of the footwear is. So there's some good information out there. And I would recommend people look at the Health and Safety Executive Grip Rating Scheme. Obviously, that's based within the UK because it's the HSE, the UK regulator, but the information from that test is valid. It's based on a valid test method, and it's asking the question, at what point does the footwear fail in a range of challenging conditions? And that gives a rating of 1 to 5 stars. And the idea is that not everybody needs a 5-star shoe. That's for a specialist environment with oily and greasy contaminants. But even having a 2-star shoe is likely to put you in the top 50% of performers on the market from the previous work we've done. And a 3-star shoe is as good as you'll ever need for wet slip resistance. So what we've got here is an example of a footwear manufacturer that I've worked with a lot. I helped them develop this soling pattern, and it's typical this of what gives a good slip resistant sole. And it's an example of a 5-star shoe on the HSE grip rating. And that's lots of these very narrow channels, because it works a little bit like a car tire. The physics is slightly different, but it works in a similar fashion. When you walk on a liquid or a very viscous oily contaminant, the footwear flexes and expands, and these channels force that contamination out from under the contact patch, so you still get some contact between the rubber and the floor. So there's lots of misconceptions around footwear. If we put good slip resistant footwear in, we're going to start getting trips because people will have too much grip. And that's not how they work. These pieces of footwear offer very little in terms of any more slip resistance in clean, dry conditions than a typical work shoe would. But when it comes to dealing with the viscous contaminants, they're able to maintain some of that contact and give you the grip. So we'll talk briefly now, and then we'll have time for questions on preventing trips. And it's all too brief is preventing trips in these sessions, because trips are quite obvious, generally speaking. But because of that, I think we're generally quite bad at dealing with them. It's very easy to see either a permanent hazard in an environment, a single step, a doorstop, or a mechanical defect, a broken piece of flooring, or even something that's been left out, a housekeeping issue, trailing cables in walkways and so on. It's very easy to see that and say, right, well, I've seen that and stepped over it, so I assume that whoever's behind me will do so, and then you carry on. And unfortunately, the person behind you may not see that issue and might trip over it. So I suppose the scientific question is, how high does something have to be a trip hazard? And this is your example right here. It's about 10 millimeters high, about a centimeter high. So the research shows us that for a healthy working age population, the average toe clearance or foot clearance, which is the smallest distance between the foot and the floor as your foot swings through in the swing phase of gait, is between about 8 and 22 millimeters. So anything 10 mil and above has the potential to trip up a healthy working age population. And as that size increases, the risk increases in a wider phase of people's gait. Practically speaking, in the UK, highways engineers, when they're maintaining pavements and public walkways, will typically use about 25 millimeters, about an inch, as the height of to take action. So that'll be their action value, but it's done on a risk assessment basis. So if it's a busy high street outside, a charity shop or an environment used by elderly people, they might act on a lower threshold. If it's somewhere that doesn't get a lot of pedestrian traffic, they may leave a defect with a higher threshold. But that sort of 1 inch is where people tend to start. But anything 10 mil and above has the potential. In terms of preventing trips, all of these bits of information are very obvious, but the last one on there is quite critical, particularly when it comes to maintenance defects rather than housekeeping issues that individual people can address as they see them. If you've got a broken tile, if you've got a stair securing device that's come loose, or a carpet tie, or whatever it might be, having a quick, easy reporting system, similar to the proactively system we talked about at the start, allows people to identify those quickly, send them into maintenance, get them dealt with. So preventing trips is really about a bit of education, understanding, and then sufficient lighting, storage, and so on. So I'll finish off talking about preventing stair falls, and stair falls are a beast all to themselves. And unfortunately, if you fall on stairs, particularly if you're descending the stair, you're falling from height and you're landing on an uneven surface. So the chance of serious injury and even fatalities is relatively high. And the vast majority of investigations in my career have been stair falls, and they have typically been fatalities. The sort of level of event that triggers my involvement. Falls on stairs are typically seen as completely human error. If the stair looks okay, presumably it's built to some local building code, it meets relevant standards, and therefore if somebody fell, really they should have been paying attention. Now, the use of stairs is a highly subconscious process. It's a very difficult cognitive task. So to do it safely, you need the right physical and visual cues to make that journey. So actually the most significant influence on the likelihood of human error is not the individual and their capabilities, it's typically stair design. So the dimensions of the stair treads, the consistency of those dimensions, the visibility of the nosing or the edge of the tread, and the availability of handrails makes a big difference. So I'm just going to show a couple of practical examples here, and then we'll wrap up and talk about questions. So in terms of the highlight at the edge of the tread, the nosing highlight, this is, I think, quite a good example. This is some photos I took in a quarry environment, and I went down these stairs very carefully because I'm not great with open gridded stairs. And as you can see from here, it's very hard to work out where the edges of the treads are. Sitting at home or in the office looking at this presentation and looking at the photo, we can easily work it out. But I wandered down these quite unsurely, and then I sort of jogged down the next set to catch up with the people who were showing me around. And I thought, why did I jog down the second set when I could barely walk down these? The second set were very similar, but they had a highlight on the edge of the tread, little piece of metal welded onto the nosing. Not an example of excellence, not the greatest solution in the world, but look at how much more effective it is. Look at how well your brain picks out the treads in this picture compared to this picture. And it's because it isn't a conscious process. You can't, unfortunately, tell people at the top of the stairs, pay more attention and don't die, and expect them to pay any more attention and not die. It's a subconscious process. They need those physical and visual cues to accurately place their feet and to judge how far the next step is. As a further example of this is an external stair leading into a control room, and as you approach it and go up it, that's obviously a set of 3 steps. When you come back outside that control room, that set of 3 steps is much more difficult to see. Immediately, that visual distraction, there's no highlight on there. They look very obvious from one direction, but not from the other. So what the organization decided to do here when we'd identified this issue was to highlight the edge of the treads. And I think we can all agree the highlight is very effective. It's in bright, beautiful health and safety yellow. Actually, yellow is not always the best highlight color. We tend to think of yellow as a safety highlight because it's very bright, it's very obvious, and sometimes we put it next to black, and yellow and black have good adjacent contrast. In this case, I'm going to argue that this highlight is not effective, and I'll show you why. When you're using a stair like this, you don't stare at the edge of each of the treads. Typically, as we walk, we scan our environment for hazards. If you're scanning the environment here, you're unlikely to see that set of steps. The handrail is a bit of a visual cue, and you might notice that you're at a different level to where you're going, but you cannot see the edge of those treads. When you're scanning the environment here, you're using your peripheral vision, and your peripheral vision doesn't see color. What you detect in your peripheral vision is the difference in the amount of light coming back off a surface, and that's completely irrespective of color. So if we look at this picture in black and white, the way we would see it in our peripheral vision, that highlight suddenly stops being effective. If we look at the 2 upright metal posts in the background that are a dark black against the pale concrete, they remain visible and effective, but the highlight disappears. So understanding some of that science behind what gives rise to risk and what you can do to fix it is really, really important. And the same applies to handrails. So this handrail here does not contrast with the wall. Now, when we're sitting looking at this photograph, it's very obvious where the handrail is, and you assume that people would use it. Actually, there was some research done, wasn't done in the UK, we wouldn't be allowed to do it over here, but basically people were forced to fall downstairs. It's a fantastic piece of research. What they did was they had a stair rig that could be shaken, and the individuals were wearing a fall arrest harness, and they walked towards the stair, and there were 2 test conditions. In one, the handrail was the same color as the wall, just as we see in this picture. And in the other, the handrail was painted a contrasting color. So as people walked towards the one with the contrasting material, their gaze rested on the handrail as they approached the stair, usually 0.3, 0.5 of a second. They measured it with gaze tracking goggles. What that meant was that on the occasions that the stair was shaken, those people knew already in their spatial map where the handrail was. They reached for it largely with peripheral vision, and they had about an 80% success rate at arresting the fall. In the test group where the handrail was the same color as the wall, nobody gazed at it as they approached, which meant that when the stair shook, they all started looking for the handrail, and by the time they'd identified it, they'd all fallen. So just a lick of paint on a handrail can make a big difference to risk. Now, you've been a fantastic audience. Thank you very much for bearing with me. I hope there's been something of interest for everybody in there. I tried just to cover all the bases on a very light touch approach, but like I say, I quite often do this on a full day or even a 2-day course basis where we really dive into some of the technical detail. But hopefully these messages have come across. Falls can be prevented. That's the crucial thing. And the solutions are typically quite simple. They're often quite cost effective as well. But you need the right evidence to get the solution to the problem you've got rather than somebody's good idea. And that means beware of test data, because there are lots of different tests out there for flooring, for footwear, and they're not all created equally. They're not all giving good information. And beware of experts. There are a lot of people out there with a vested interest who will come up with a great solution for your floor, and that solution is buy my product and treat your floor. They will maybe even do free slip testing and all sorts of things, but it isn't helpful. The scientific evidence base for slips, trips and falls is out there, and it's really important to use it because it has a significant impact on risk. I hope that's been useful and interesting, and we have got a little bit of time, so I'll now take any questions we've got.
Thank you, Rob. That was an excellent presentation. I'm amazed you managed to cover so much in such a short amount of time. We don't have any questions through as yet, so if anybody does have a question for Rob, if you want to pop it through now, Can you leave us? Oh, here we go. Oh, great session. Anything I had to ask was covered. Well, that's the biggest compliment that you could wish for.
I always assume if there's no questions, it's because I covered everything perfectly. But thank you for thank you for confirming that. I also
oh, here,
appreciate I threw a lot of information out there. So if you are a bit shell shocked and something comes to mind afterwards, then my contact details are on the screen. Do feel free to get in touch.
fantastic. We have had a couple of questions. It does
Oh,
normally
brilliant.
incite a few questions. So, what rating of footwear would be best suited to roofing works / traditional slating?
Right. I think if you're looking at the HSE grip rating, which we talked about, which is really the only way to look at slip resistant footwear with a good objective measurement, 3-star footwear should be fine for roofing because that's the best level of grip that you're ever going to need in wet conditions. So it gives you the absolute best level of wet slip resistance you'll ever need. You're unlikely to need 4 or 5-star slip resistance, which is the same in the wet, but also better with oil and more viscous contaminants, unless you're doing anything with the roofing works that involves a more viscous substance than water. So if you've got any adhesives, bonding agents, anything oily and greasy up there, then 4 or 5-star footwear would be more appropriate.
Great, thank you. So the next one, thanks for this, and interested in your comment on Highways Agency. My understanding is that they have a higher leeway than other organisations. So can you clarify this, please?
Absolutely, and I think that's generally very true. So their action value of an inch is 2.5 times what the research suggests could be a trip hazard. Certainly, HSE's approach when I was there was always trying to avoid anything 10 mil and higher, and that's what I advise all my clients is if you have a hazard that is higher than 10 millimeters that can't be removed, it needs to be clearly highlighted, as we talked about under the stair nosings, you know, the idea of light reflectance value contrast, or if possible, if you've got a hazard that's more than 10 millimeters, then can it be removed or can it be addressed in another way? So I would say 10 millimeters is a much more practical way to manage that risk.
Great, thank you. And this is another thank you, very interesting. And I really didn't know about the peripheral vision and lack of colour perception. That was really interesting, actually, seeing the
Yeah,
demonstrations of how a colour can change a perception.
it's funny how these topics sort of jump out at you. When I joined the health and safety executive, my intention was to be there for about a year. I thought I'd probably be investigating accidents and then defending claims, and it would all be a little bit no win, no fee sort of lawyer speak. And actually the science behind slips and trips is physics, it's biomechanics, it's human environmental interaction. It's fascinating. It's why I'm still here 20 years later. And it's a perfect blend for me of the technical and the nerdy, which, you know, you wouldn't think to look at me, but I'm a huge nerd. But it's also very practical. We can take that information and in the space of 24 hours, we can do things in a workplace that reduce the risk for people and make people safer.
Great, thank you. This is interesting. What's the best starting points? What are the best starting points for scientific data? I'm not sure if that's a quick answer or a very long one.
It's a challenging answer. I'll give you the very quick answer. When I'm working with a new client, the very first thing I typically recommend is a review of their data. And typically what I will do is I'll look at 500 of their most recent reports, whether they're good practice, near misses, hazards, incidents, claims, whatever information they've got. And I tend to look through the free text boxes to read the descriptions, and then I categorize based on what sounds like happened. So whether it was a slip, a trip, or a fall, which are very, very different things. And often my classification is very different to the way they've been classified by the organization. And so that's usually where I would start, is about 500 data points, looking at it in depth from a specialist point of view, because that helps identify that low hanging fruit. You know, what's the easiest win for that organization to help to start reduce risk? And then based on that, you know, with an organization, we may then move to training, we may then move to video materials, or we might do site visits and write them company standards. But that data is always where I like to start. If they've got a system like the Proactively system, that data is very easy to query and analyze. Typically what I see is a large Excel spreadsheet with very little information in it, actually. And one of the things that we typically start our reviews with a new client is the gathering of data. But yeah, I think the gathering of that evidence is really, really critical. Hopefully that answered that question, but if not, do feel free to email me and we can carry on the conversation.
Great, thank you. That was a succinct answer to rather a large question. Okay, so that's all the questions. Got numerous comments. Thank you so much. Great presentation. Thank you. Really informative. So that just leads me to thank you so much for giving up your valuable time today, Rob, to present to the Scotland branch members and other IIRSM members. I'd like to wish you a happy Christmas, as it's not far away now, my first one.
No.
And I know, I'd like to wish everyone a good afternoon or a good evening wherever you are in the world. And just to remind you, the video will be uploaded onto the IIRSM YouTube channel in the next couple of days, and your attendance certificates will come out this time tomorrow. So thank you, everyone, and goodbye.
Thank you for having me.